Hey everybody, welcome back. Let's do another end-to-end project video series. This one will be about 3 videos long. In the first one, we're going to model up the parts. In the second, we'll set up an assembly. And in the third, we will set it up in the path workbench for cutting and actually cut the parts out on the laser cutter. Our project this time is really simple. It's a little finger joint box or a rack for holding Altoid tins for storage. But the way those finger joints work, there's a critical dimension dependent on the thickness of the material. So we're going to make it parametric so we can adjust that depending on the material that we're cutting and have the finger joint sizes adjust appropriately. So hope you follow along and let's jump right into it. The first thing I'm going to do is create a new document and then switch to the spreadsheet workbench and create a spreadsheet. And then I'll click on that node in the tree to open up the spreadsheet. Now what I want to do is create some cells to contain values. And first I'm going to type in the labels here. So I want the thickness of the material, and I want the overall height, width and depth of the whole rack, and then I also want to have the width of the finger joint tabs, so we'll call that tab width. And then I can plug some variables or some values in here. So I'm going to start with 3. We'll make the height 220 millimeters. The width is going to be, let's see, let me measure my old one, and make that about 70 millimeters by 85. So 70 and 85. And I'm going to make my tab width 15 millimeters. Now right now these are just values in the cell, so I need to make them accessible. I could actually get to these from the expression editor, as you'll see, but it's helpful if I turn these into aliases so they're a little easier to reference. And you do that by right-clicking on Properties and switch to the Alias tab. And I'm going to use the same, for the alias, I'm going to use the same thing I did for the label. So this is thickness. And then while I'm here, I'll switch to display unit and type in millimeter. And when I say OK, you can see that the background of the cell turned kind of a pale yellow, and it's now showing 3 millimeters, even though I didn't type in the unit string. It's displaying it that way. So I'm going to go ahead and do the rest of these the same way. Okay, now my aliases are all set and the unit strings are set. I'm going to switch to the part design workbench. I'm going to create a body and a sketch, and I'm going to do this on the XY plane. And it's a relatively simple part. It's basically just a rectangle, and I'm going to center this on the origin, and I'm going to pick 2 diagonal vertices and the origin point, and then set a symmetry constraint, and that'll keep things centered around that origin. Now I have 2 remaining degrees of freedom in here: the width of the back plane and the height, and that's the width and height of the overall rack. So I'm going to set constraints on those. So I'll set a horizontal distance constraint and click on the expression editor, and you'll see this is where it pops up in the background here. So I type spreadsheet .width and press enter, and there's my window in the background. So I say OK on that. And you'll see that the constraint turned an orange color. That indicates that it's linked to something external. And now if I set a vertical constraint, this is going to be to spreadsheet height. Okay, now my sketch is fully constrained. Now I might as well go ahead and add the hole in the back here. And so we'll just draw a circle, and I'm going to constrain it to be on that vertical axis. And I'll select it and give it a radius of 2 millimeters. And then I want to set the distance from the top. And we'll just set that at like 15 millimeters. Now I'm fully constrained, and I can close it and now pad it. And it'll suggest padding to 10 millimeters, but what I want to do is set that to the thickness property, or the thickness value from my spreadsheet. So this is going to be the same thing again. I'm going to type spreadsheet dot thickness. And say OK. Okay, so that gives me the back. The next thing I need to do is add my my fingers to the sides, and that's actually easier than you'd think. I'm going to select one side, and I'm going to create a sketch on that side, and I'm going to add references to two edges, the top and the well, it's now the front and back faces of that. And then I'm going to draw a rectangle, and I'm going to lock to the opposite corners to those two sides that I just put on there. So now I've got a sketch, a rectangular sketch for the finger joint, and it's got 2 degrees of freedom. One is its position this way, and the other is its size. Well, obviously I want its width here to be my tab width. So if I select that edge and select the horizontal constraint, I can, oops, this is going to be spreadsheet dot tab width. And now I have to decide where I want to position it. And I'm going to do the same thing. I'm going to just select these two vertexes, or points, I guess, and set a horizontal constraint. And I'm going to do exactly the same thing. And we'll set this to spreadsheet tab width, like that. Now it's fully constrained. I'm going to close it, and then I'm going to pad it. And I'm going to do the same thing again and pad it to the spreadsheet dot thickness value, and that'll bring that 3 in. Okay, so that gives me one tab, and what I need now is an array of these running along the side, and then a mirror array to the other side. And I can do that with a linear or a multi-transform feature. That's create a multi-transform feature. So I'm going to select pad 01, and the first thing I'm going to do is right click down in the transformations. Let me see if I can. Okay, so at the bottom there's transformations, right click to add. So I right click and I select a linear pattern, and you'll see that it suggests one additional one. I don't think all the values are in here. Scrolling down, it gives me 2 occurrences over 100 millimeters. Well, I want 5 of these, so it's giving me 5 now over 100 millimeters, and I want this to run the full length. Well, if I set it to, my height is 220, but that's going to be 220 starting from the position in here, which is too much. Let me just type it in, 220, and you'll see that my 5th one is no longer intersecting the base body object, so it highlights in red. So I need to bring that back to about 180, I think. Okay, so now you see all 5 finger joints are there, and that looks pretty good. The only reason that these numbers are important, I could put just about anything in here, but I have to use exactly the same array setup when I cut the notches on the side panel. So I'm gonna do the same thing, 5 over 180, and I'm gonna use the same tab width starting position and tab width actual width. So now, before I click on OK, I'm going to right-click in here again, and I'm going to add a mirror transformation, and I'm going to mirror it across this YZ plane. which will give me the other side. And now if I say OK and OK, there's my back piece, more or less finished. Now you see that I have these additional edges that are in here, and I don't want those. They may mess up the laser cutting when I do set it up in path. So if I just select the tip object in the body, there's this refine property that's set to false, and if I set that to true, you'll see that all those internal additional lines or edges are removed. So that should be it. My back piece should be done now. Modeling the side panel is almost identical to modeling the back, except that the finger joints are only along one edge, and rather than stick out, we're going to use a pocket operation to carve them in. I'm going to speed this up so we don't bore you with the details until we get to the cutting of the slots in the middle to receive the fingers from the floor. Next, I need to draw the holes to receive the finger joints from the floor. So I'm going to select the face and do another sketch on here. And I'll draw a line, and we'll make it a reference line to correspond to my floor. And I want the floor at an angle. And for right now, I'm not going to set the length on it, but I know a few things about this. For instance, I know that I don't want this endpoint to intersect. I don't want it to cross this line because that will be the back wall, so I don't want it to interfere. So I'll need some reference geometry. I can select the bottom face, we'll set this edge, and I might use the front edge as well. Now I'm going to take these two vertices and make a horizontal constraint between them and set this at about 4 millimeters. So that means that the edge of this can't come within 4 millimeters of the back wall. I want the floor to be at an angle of 20 degrees, and I want the bottom of the floor 10 millimeters off of the bottom of the box. So I have 1 degree of freedom left, which is the length that's on here. And for right now, I'm going to leave that unconstrained. I need to center my two holes, and so what I would like to have is a midpoint on this, and I can do that by drawing a line like this, and then selecting the two vertexes or two endpoints and my other line and setting a symmetry constraint. And you'll see that it automatically makes it perpendicular, but it can slide along here. Then by selecting the two endpoints of the baseline and my new one and setting a symmetry constraint, it'll put it in the middle. So right now I've got 2 degrees of freedom, one of which is the length of this reference line, which I don't really care about, so I'll just set it to whatever it is. And now I'm back to that 1 degree of freedom corresponding to this. Now I need to draw the profile of the slot holes, and they're going to be rectangles, but if I were to use the rectangle tool, they would be horizontally and vertically constrained, so I'm not going to do that. Instead, I'm going to use the polyline tool, and I'll draw the first line, and then pressing the M key cycles through magic mode, and the first click, it makes the line perpendicular, so I'll just repeatedly select the M key and draw the next line, and I'll end up with a rectangle. And in fact, by clicking on my line, I've already constrained the base points to it. Let me do that one more time for the other slot. Okay, I missed one, so I can set this point on the line. Now I'll select the two top edges, make them equal, and select one of them and set a length constraint and make that equal to spreadsheet tab width, and one of the vertical ones and set a constraint on that. And you'll see I'm using the length constraint, not the vertical or horizontal, since these are on an angle. And we'll set this to spreadsheet thickness. Okay, looks like I missed one point if I set that one on the line. Okay, and I'll need to make sure that my sides are of equal length. Okay, now I can select two of the endpoints and my reference line and set a symmetry. Now the only thing that I have left to constrain is the distance between them. And that's kind of not a critical dimension, but it needs to be the same here as the floor, so I'm going to set it to 25 millimeters. Okay. Now you see that this is why I didn't lock the length of my line before. If I set the length now to 60, it pushes it down where it's inside, and I can actually go a couple millimeters longer. That's too long. It's still a little long. And that's close enough. All right, I close that and pocket through all. And that should give me my finger joints. I'm not quite happy with the position on that. I may want to reduce my distance between the back wall and pull that down a little bit. Let me do that. That looks a little bit better. Now it's time to model the floor, and the floor is a lot like the side and back. It's just a rectangular shape that's centered around the origin. We set a width on it from our spreadsheet width property, and then pad it out to thickness using the spreadsheet thickness. We'll draw a sketch on the side wall and draw one of the tabs, and I'll set the distance of the tab half of 25 millimeters from the y-axis line, and then we can use a multi-transform array to make copies of it mirrored in two directions. And then finally we set the refine property to make it clean. When I was drawing the base shape of the floor, you may have wondered why I didn't set the length constraint on this. And I'm going to show you why, and then we're going to come back and fix it. Hiding the floor and showing the side panel and opening up the sketch that we used to draw the side slots. You'll remember that we used this reference line to correspond to the length of the floor. We wanted the back to not interfere with the back wall, and we wanted the front to come out close to the end. Well, I could set the end point of this line onto this front edge line, and it would automatically adjust the length for me. But in this case, I don't want to do that because I want to create what's called a named constraint for this line so that I can refer to it in the other sketch. If I double click on here, you'll see that I've added into name optional, I've given it a name of floor len. And now if I close this, hide my side panel, it's important to know that this is sketch 004, and you'll see why. Show my floor again and go back into the sketch that draws the base shape. Now I can select this edge and set a vertical distance constraint, and I can use the expression editor, and I'm going to use sketch 004, and you would think by typing floor len it would give me what I want, but that doesn't quite work. And you'll see that the property editor is giving me a red warning here. And it's because that named constraint is part of the constraints collection. So you got to type sketch 004 dot, and as soon as I type the capital letter C, it suggests floor length to me, and if I choose it, you'll see that I get sketch 004 dot constraints dot floor len. So that's how we refer to that, is the dot constraints and then the name that was on there. And if I say OK, you'll see that it brought the 62 millimeters over here, and it gave me an orange constraint, which indicates that it's locked to something external to the sketch. That way, if I needed to go back and adjust the size, I could do that very easily, and I wouldn't have to adjust my floor size. So coming in here, you'll see that my part has adjusted its size, and my tabs are in place, and I think we're ready to go. Okay, that's everything involved for modeling the 3 pieces for this rather simple project. In the next video, we'll create clones for them and do an assembly so we can see how they fit together. If you got better, more elegant ways of doing these things, please leave a comment below. If you got questions, I'll try to answer them. That's it for now. See you in the next video.